Hey world, good morning. Jessica Kirsh here. It's February 21st, 2020, just about 7 a.m. in Phoenix, Arizona. And I am headed down to Mesa, Arizona to the brand new Atlis Motor Vehicle headquarters. They're doing a battery day today for their introduction of a fully sized, completely electric pickup truck. I don't know much about them. I should have done probably a little bit more research, but I figured what better time than today to go down there, learn about the company, ask some questions, and maybe get a little insight onto the actual live happening now competition that is developing for Tesla in the Cybertruck. There's Rivian, there's Bollinger. So anyways, I'm gonna finish up, get in the car, got my gear loaded. I'm geared up, literally and figuratively. Not yet, I haven't had my coffee. I am tired. Whew, I did not sleep much, but I'm excited. Hopefully I can bring some news about this 15-minute battery recharge. I'm getting on the highway, so this is gonna be real quick, but I'm headed down to Atlis Motor Vehicle headquarters in Mesa, Arizona. I'm 28 miles away. The battery day starts at 9 a.m., the presentation. So I'll be coming to you with content during the presentation, maybe, and then also afterwards. So stay tuned for content. Oh, there's a nice Model S right there. Speaking of electric vehicles. TikTok goes the gas pump clock. Yes, I still have an ICE internal combustion vehicle in my ownership, but I look forward to the days where I will be able to recharge using electric rather than gasoline.
I've got a suspicion that you look perfect next to me. All right. And you can call me crazy, baby, but I call it destiny. Ooh, you make me wanna throw my hands up, throw my hands.
What is this? Atlas. They've got little yard signs. Look at that.
Okay, I just pulled up to Atlis. Just walked in, I stepped foot inside, and Mark is the CEO, and I just met the Tesla Owners Club of Nebraska. So I'm excited to meet some more people. I'll be bringing you more as the day goes by. I'm coming to you from Atlis headquarters. Here we go. Whoa! Today is battery day. We're in Mesa, Arizona. It is a cloudy but beautiful day. I'm excited. This should be really interesting. This is great. Yay, competition for Tesla. It's good. We're headed in. Here we go. Sorry, can I squeeze there? Thank you. Starting to fill up.
Quick question for you.
Yeah,
What's your name?
my name's Jessica. Hi.
Vincent.
Good beard.
Thank you. I noticed your name tag sitting on the ground.
Is it not on my back anymore?
No, it's on the ground in there.
That's why I put it on my back so it wouldn't come off on my front. All right, can't keep a name tag on. Sounds like me.
20 hours that we got into the building. So
Yeah, so this is a big deal. When I stepped in the front door
Right.
and there was this on the wall and 3 people standing there, this is a big deal.
Yeah, it is. Pretty much work overnight. The entire
That's
team.
so cool.
It's awesome.
Way to make
We're
it
very
happen.
excited.
Yeah.
Because it was tight in the garage.
Oh my God. That's very cool. Thanks, Mike. 20 hours. Okay. Presentation's about to start and whew, already sweating. Here at Atlis. Dun-dun-dun, dun-dun, dun, 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 dun. Yeah, I know. Okay, we're going to the warehouse. Excuse me. Dun-dun-dun, dun-dun. What's your name?
I'm Wade.
Wade! Oh my gosh, I have a good friend named Wade. Hi, Wade. I'm Jessica.
How's it going, Jessica?
How long have you worked for Atlis?
Actually, only a few weeks.
Wow, well, welcome. Not welcome, I'm not part of the team, but congratulations. Very cool. You excited?
Oh yeah.
Big day today. Big day. Very excited. Oh wow. Here we go. Going on into the warehouse. The warehouse. Oh my gosh. Look where we are. Lots of EV people here. There's investors, there's competitors. Look at that sexy piece of machinery. This is Jerry. He's the owner of Tesla Owners Club in Nebraska. Oh my gosh, I wish I had 10 more arms. Thank you. That's me. This is very cool.
What was the last?
Kirsh, no C. There's no C in it. Are you on Twitter or are you YouTube? Yeah, that's me. Okay. Yay, subscribe.
Yay, definitely.
Yay.
I got a whole bunch of stuff.
Yeah, thanks. Working on it. This tripod is heavy. I need more arms. Okay, I'm gonna go set up. Starting to fill up though. They moved in here less than 20 hours ago. Less than 20 hours ago.
Yeah, that's crazy.
That's insane. Wow. Way to make things happen. We need more people like that in this world.
This is what we built roughly early last year as kind of the concept, and now we're moving to the next phase, which is going beyond just sheet metal welded together, right, and some concept stuff, so trying to move this towards production.
Whew. This is very cool. It's very cool to live in Arizona and have this be in Arizona, local to Phoenix. This is a big deal, everybody. I'm excited. I'm ready for this presentation to start.
Wake up, step into the world outside. The future never
Vincent!
looks so bright. Can't you hear it calling?
You're good.
us?
All these people! This is so cool.
All of your cares behind.
They moved in here less than 20 hours ago. Way to make it happen. Warm. Very warm.
We can sit and talk
I'm
about
gonna set here shortly. I'm very excited.
we don't have to stay. We could run away. Oh, we could run away.
Bringing it on. Might as well, right? I'm gonna drink some more water. Don't have enough cans. I should have brought a hydration pack. Come on, Jessica. Let's think. Go rolling in here. Yes. They started. Wow, there's some people here. Are you guys excited? Waiting on the presentation to begin. About to get started. This is pretty exciting. Here it comes.
Can everybody hear me okay?
Louder.
Fantastic. There's a nice echo back there, so you get to hear me at least twice today. For those of you that I haven't had a chance to talk to yet, my name is Hanchett. I am the CEO of Atlis Motor Vehicles. The way we're going to do this today is that Abel and the engineering team here in the back, as I'm giving the presentation, they are actually going to start a charging demonstration, okay, with battery technology that we are developing. It is all hidden behind a curtain and a black box. I'm sorry, we're not going to show you the details today. We do have some competitors in the audience today. We don't necessarily want to share some of our secrets. But if you look at this screen right down up here, we have two things going on. We have the industry standard, and then we have Atlis Motor Vehicles. And And you're going to hopefully see a flawless demonstration today of the battery technology and ultra-fast charging. Okay? Now, the way we want to kick this off is I'm going to talk about where we started. We started in my garage. If you're following social media, some people were very kind enough to point that out. That the address for Atlis Motor Vehicles was my personal house. We started off with 5 individuals, 5 team members, 5 people that were willing to take a risk, that were willing to do something that no one else wanted to do. It's not just about building a truck. It was about building a truck that was truly competitive, truly capable, truly able to change the world by being better. That is what we do. And we started with battery technology. That is the most important thing. And it all started right there behind that door. Since then, we've grown to 14 individuals. We've seen some of them walking around here today. I believe everybody's here. And we'll share a nice little picture of everyone there at the end. But that's the origin of Atlis Motor Vehicles. We are not physicists. We are not scientists. We are people that use this truck. We are people that are very interested in technology. We are people that were willing to do something different to really change the world. Now, who are we building for? We are not building adventure vehicles. We are not building lifestyle vehicles. We are building vehicles for those that do work. Some of you saw me earlier today hold my fingers up and talk about how my fingers are stained in grease. They're stained in dirt. That is because I work on vehicles. I work on our vehicles. The team that's sitting back there in the black and white and orange shirts, they're all people that get their hands dirty. They're all people that work on vehicles. We're people that tow, we're people that haul. But we're building vehicles for those that keep our lives moving. We're building vehicles for those that work in construction, and those that work in agriculture industry. We're building vehicles for people that do work with those vehicles. Maybe you like to tow an RV on the weekend or a boat on the weekend. Maybe you use your vehicle for work every single day. It's your livelihood, it's what you depend on. That's what we're doing. By focusing on building new technologies for that particular market, we can deliver an experience that is far ahead and beyond what you expect today. Now, if you guys have you already started the demo there, Abel?
Not yet.
Okay, so when you're ready, please go ahead and start that. Now, I talk about performance and cost being one of the biggest factors. Yes, electric can tow, right? We know it can. We can produce so much power and so much torque in a short period of time. We know we can get that load up and running and going, right? Whether it's payload or you're towing something. But where most of our customer base we find makes a decision or where they're interested in is really, it's that performance side, but it's also the range side. It's also when you're towing, right, that 500-mile range goes to something that's less. So that means if you're towing something, you go from, say, 6 hours of driving capability to maybe 2 hours. If you have to stop and charge for another hour, that's an extra 50% of your time added to whatever trip you're trying to do. We're trying to bring that back into scale, right? We're trying to bring that back to what you have today with, say, a diesel pickup truck or a gas pickup truck. That's the motivation. Now, the next thing, of course, is cost. In electric vehicles, yes, long-term ROI on that vehicle might be better, right? Over the period of 10 years that you may or may not own that vehicle, okay, the long-term cost is always less, but a lot of us really like to make decisions based on that upfront cost. So what can we do to drive costs down? How can we make that appealing? How can we bring vehicles to more people? That is the most important thing that we can focus on and we can do. That's what we're doing here, okay? Now we know the future is electric. We know that's happening, but again, we know it's happening, we know people are using it for work, but again, there's still shortchargings today, right? If you've ever towed with a Model X, right, and the range drops to 100 miles, it's a very, very, very scary experience, especially going from charging station to charging station. And of course, those of us that do work, or those of us that are doing work every day, it's a tough job, right? It's a challenge. And by the end of the day, you're definitely tired, right? It's definitely something where you're looking at it and you're saying, hey, you know, my job is tough, right? I want to get home. At the end of the day, you don't want to spend any more time of your day actually traveling home, right? Plugging your vehicle in, right? You want to go and see family, right? You want to focus on family. That's where you're headed, right? You don't necessarily want to go and sit at a charging station for an hour. I know I don't. After taking 2-3 road trips in the Model 3, that is one of the most daunting experiences ever, especially when you have 2 little kids in the car. The video games can only last so long, right? And waiting and waiting and waiting, that's a headache. And we talk about work and we talk about towing, right? If you can only tow for 100 miles or you can only tow for 200 miles, imagine doing that and then sitting at a charging station for an hour or more, especially as battery capacities go from, say, 100 kilowatt hours to 185 kilowatt hours or 250 kilowatt hours. Your charge time is definitely going to extend. Now, our focus has been on the XT pickup truck. That's that sexy, cool thing that everybody in this room is probably familiar with, right? That's the thing you can touch, right? That's the thing that's very interesting. That's the vehicle that's really going to deliver that experience. If you own a gas or diesel vehicle today, we want to deliver a vehicle that beats that in every way that matters. That's our focus, okay? In range, 500 miles of range. When you're towing, we want to get that as close as we possibly can to your diesel and gas experience today. And of course, when you have to charge, do something like that, we want that to be very, very quick. When we talk about towing, we're not talking about 8,000 pounds of towing. We're not talking about 10,000 pounds of towing. We're talking about 35,000 pounds of towing. We're talking about 1 ton and bigger vehicles, okay? Those of you that do work, maybe you tow a horse trailer, right? Maybe you're towing construction equipment. Maybe you're towing supplies right to a job site. Maybe you're just towing an RV for fun on the weekend. We want to be able to deliver an experience that goes above what you have today. And of course, what everyone wants to see today is that 15-minute charge time, right? We want to see that vehicle that can really plug in, and 15 minutes later, after maybe you've grabbed a snack, you use the restroom, you're up and running and you're gone again. And not just 15 minutes to 80%, not 15 minutes to 100 miles, not 15 minutes to 50 miles. We want to do 15 minutes to 500 miles of range. That's what I get today. That's how my diesel truck works today. That's what Atlis is going to do. That is the most important thing we can accomplish. Now, how do we do that? You cannot do that with off-the-shelf battery cell technology that exists today. Cylindrical cells, prismatic cells, pouch cells, right? None of those work. The chemistry is one piece of it, but the other side of it is how those cells are actually constructed and what we do with those cells. That's what we're focused on. While others focus on chemistry and solving the problem that way, we are combining chemistry with a completely new cell design, with a big focus on thermal efficiency both in the cell as well as the pack. Now our pack design is rather unique. What we're doing from a temperature and thermal management perspective is think of it as taking a Yeti cooler, stuffing a bunch of batteries in there, and then integrating an HVAC system in that. Back there, for those of you that would listen to me earlier, I talked about the fact that it's a self-contained system. What if your battery pack could rise up to temperature? Let's say it's room temperature, or let's say it's higher than that. What if your pack could do that? What if you could park it in northern Minnesota and have it maintain that temperature for a long period of time? Let's say it's overnight until you run it again, or maybe it's a couple of days again before you run again. I grew up in northern Michigan, right? My dad used to run a wrecker and repair service. He also used to plow people's driveways and roads when I was growing up, okay? What if we could build a vehicle that every morning, every time at 2 a.m. when he got up and he had to go out there and he had to pull somebody out of a ditch, he didn't have to worry about whether or not that vehicle was going to be capable of doing that. Maybe it's sitting outside and it's not plugged in. Maybe he didn't have that ability. He could get in that vehicle. He could go out to wherever that vehicle is. He could tow it out of the ditch. He could tow someone home, right? He can go plow some old lady's driveway if she can't do it herself. Build the vehicle that is capable of doing that. Build the vehicle that you can rely on today. Now, from a pack perspective, holistically, it's a completely insulated pack, right? It has its own HVAC system. It doesn't share with anything else. The reason why we do that is because the pack owns its own destiny, right? We don't want anything else to actually affect that. And when it comes to some of the technology we're developing for fast charging, that is one of the most important things we do. Oh, big blank page there. Oh, clicking the wrong button. Okay. Now, we talk about extreme temperatures. We live in Arizona, right? We have extreme hot. I'm from Michigan. That's not somewhat extreme cold. It's not northern Minnesota cold, but it's definitely extreme cold. Again, we want a vehicle that can work in both. Here in Arizona, you can actually drive from a hot temperate climate to a cold temperate climate. You can do that in a couple of hours. What we don't want to have happen is let's say your range starts at 500 miles, and by the time you get to that cold climate, right, that range drops to 200 miles. Okay? So how do we do that? Again, you can kind of do it with cylindrical cells or prismatic cells, but we really had to build something new. We had to build something that could perform in those different conditions. Part of that is what I talked about earlier today, right? It's how we're doing things from a pack construction standpoint, how we're managing the thermal characteristics of it. The other part of it is this particular cell design right here that you see on the screen here is the highest performing cell in terms of thermal management of how that thing operates, right? What that means is from the edge of that cell to the center of that cell, we're talking very, very minimal temperature differences. Not on the outside, on the inside, on the center of it. Develop cell technology that allows us to get a variation of a degree or less, right, between the edge of that cell and the center of that cell. Imagine what you can do with that. Today, if you try to heat up a cylindrical cell, you try to fast charge it, you try to discharge it, you might see 5, 6, 7, 8, 10, 12, 15 degrees C difference between the outside of that cell and the very center. It's something you can't do with cylindrical cells. Prismatic cells, especially the big bricks, are even worse. So we focused on developing cell technology that allows us to really do some fantastic things from a thermal management perspective. Combine that with some things we're doing from a chemistry and mechanical and electrical construction standpoint, and now we have a cell technology that can do some very, very amazing things. Okay? Now, those of you that follow us on social media, you will remember in 2018 we did a proof of concept test. This is a very interesting photo. We have thermal management, we have a battery management system, we have a chat mode connector here. We went out, we took this pack, we plugged it into an EV GO station, and when we did that, we charged this pack in 12 minutes and 37 seconds. Now you might ask yourself, why is it so small? The reason why it's so small is because you can only get 50 kilowatts out of an EV GO station. If you can only get 50 kilowatts and a certain amount of current or voltage out of an EV GO station, we have to work within those constraints. And the reason why we did that is because we wanted an independent piece, right? If we're doing it kind of a video in front of everybody, we wanted to eliminate some of the possibilities of, say, the smoke and mirrors, right? And some of those aspects of what we're doing. Okay? Now, where does that apply and how do we apply that? Today, the concept is we take that battery technology, right, and we load it into the XP platform. Back there is the concept of the one that we built earlier. I talked about how it's modular, right, how it's expandable and how that thing works. When we load that thing in the center of it, it's also completely, again, modular system where we have identical drive systems front and rear that becomes expandable, right? We can shrink this thing, we can grow this thing, but we can still maintain that fast charge capability, at least up to a certain point where maybe we run out of power, right? If you have a 1 megawatt battery pack, the fast charge capability for that is going to be really big. Okay? And of course, that all kind of plugs into the XT pickup truck and what we're sort of pitching today in terms of capability and where we want to go from there. Now, we're not thinking about just pickup trucks. Again, that's a sexy, cool thing that you can actually touch. What we're truly trying to think about is how can we apply that to different industries? How can we build one set of technology that can grow, particularly in the sort of work market, right? How can we build a single set of technology that can be shared across that? How do we build an ecosystem of products and solutions that work together? And it all really starts with that battery technology, right? It starts with that thing that gives you the performance that you're looking for. Everything else can be built on that, right? But it's that battery technology that's at the core of it. Okay? Now, we built a pack. You can charge it in 15 minutes. But there is no charging station on the market today that can support that. A 250 kilowatt hour pack at the highest charging rate, we're pushing 1.5 megawatts of power. The biggest Electrify America station that we're aware of today is 350 kilowatts. The biggest Tesla station, I believe, is 225 or 250 kilowatts. Okay? The average charging station that's actually installed is somewhere between 50 and 120 kilowatts of power. We have to actually invent technology that allows us to charge a vehicle quickly. but it can't be applied in an application where only certain people can use it, right? My grandmother's 86 years old. She needs to be able to use this, right? She stands 5 feet tall. She can't lift this big honking kind of plug, right, and shove it into the vehicle. She needs something that she can hold in one hand. So what we're doing here at Atlis to complement it, and there's some concepts in the other room over there, but we are actually not only developing the charging station technology, but we're developing the handle technology. That handle, which you see the concept in the other room, is capable of delivering 1,600 volts and 1,000 amps, and it's the size of a CCS handle. That part is incredible, right? So now we're building the battery technology to do that, but we're also building the charging technology, right? We're doing something there to make it possible to accomplish that, okay? Now, the biggest challenge with that is not necessarily in the handle, it's actually in the cable, and what we do there. In my previous experience, we developed cable technology that was incredibly flexible. It was incredibly durable, right? If you think about charging handles and how often those things are used, these things have to survive hundreds of thousands of cycles, right? Pick it up, move it, plug it in, people are gonna step on it, right? They're gonna crush it, they're gonna try to kick that thing. It has to be able to survive those cycles. But when we're delivering 1,600 volts and 1,000 amps, we're talking about a cable that's roughly about 2 3/4 of an inch in diameter. So what we actually do is we do a very proprietary construction methodology for this that allows it to be flexible. I can't share too much about it, but the best reference I could give you would be think of a slinky and how a slinky is super flexible. Apply that thought process to the cable. Give you a little nugget there as to how we accomplish that. That's something that I've actually applied in a previous company in terms of how we construct cables, and we took something that's very stiff and turned it into a very flexible thing. Now the other side of that is solving the problems with the materials, right, and things like that. That cable jacket, right, we don't want that thing to wear out so we have an arc condition, right? We don't want a failure in the field. We want these things to work in different conditions. There's 2 ways to do that. One, solve it from a chemistry perspective and a material perspective. Number 2 is we plan to have charging stations that are in remote areas. We plan to have charging stations that are in destinations. We plan to have charging stations and maybe there isn't someone there to watch it at all times. So when that when that plug is actually plugged into the charging station, we're developing technology where we can do self-diagnostics of that system in the field, and that can run periodically. So think about a charging station that is basically doing its own health monitoring, right? It's determining whether or not there's actually a fault in that system, and then it's flagging that and then scheduling someone to come out and actually do that repair. We're talking about these high-powered systems. We can't have failures in the field, right? That's a safety risk, right? That's a customer experience problem. So develop technology that is smart, develop technology that can manage itself in such a way that we don't run into situations where you go to plug in, right, and it doesn't work anymore. We should be able to flag that issue within a 24-hour period, right, and get someone out to actually repair that. Okay? Now, how do we deploy a 1.5 megawatt charging station out in the field? Okay? One of the biggest problems is if you plug that into the grid, in some locations or some areas of the country, it is possible to do that, right? But if we want to be able to deploy these fast and we want to do it for a relatively low cost, we have to be able to develop a solution that doesn't cost $1 million per charging station to plug in. We have to develop something that maybe costs $50,000 per station to plug in, which is comparable to what it costs today for, say, a 50 kilowatt or 250 kilowatt system. So to do that, we're looking at deploying buffering systems, right? Taking the battery technology that can ultimately fast charge and survive a large number of cycles, right? And plug that into the charging infrastructure. What if we could simply just drop something like a box on a location, plug it into the existing grid connection, and be able to charge up to 8 vehicles with a system that's maybe the size of a container, right? Go out there, deploy that, do that very quickly, start rapidly moving those things. And if there's a problem, we could always just unplug it. I'm simplifying this, but unplug it, pick it up, drop another one in its place, and keep things going. Now, I said we started in my garage. Here's a final picture of the inside of it. From here, I will go into some more details of the battery technology and what we're doing there. But this is the current team we have today. We're a team of 14 individuals. We started with 5. Over the next year, we're going to grow to 75, and then by the beginning of next year, our plan is to grow to about 150 individuals as we start to ramp up in terms of engineering technology or engineering efforts, right? Primarily in development of things like the battery technology, the XP platform, and some of the different systems and things that go with that. By the end of this year, we are planning on having a production-ready single XP platform available, as well as the charging system and some of the technology that's associated with that. That is our ultimate goal. Okay, so that's a little bit about Atlis Motor Vehicles, and then here's the timeline that I just spoke about there. And from here, if you want to, we can go into a closer look on things. If you're curious about the battery technology, I have no idea how the test is going right now. If you're curious about the battery technology and things like that, we can dive a little bit deeper into that. If that's where we want to go from here. Does anybody have any real quick questions before I do that?
For home charging, is there a system that you can plug in at home?
Yeah, so we'll be putting a CCS system on the front of the vehicle. So you'll basically be able to plug into a 240 volt socket, right, with a simple charging cable, plug into the J1772 plug that's on the front of there, and the onboard charger will allow you to charge the vehicle.
So charging from the CCS out in a normal charge station, how long would you have to stay for, say, 100 miles?
Fantastic question. First of all, I talked about a 1,600 amp battery pack. Right? Or, I'm sorry, volt battery pack. CCS 1.0 is 400 volts, CCS 2.0 is 800 volts, right? At least currently. And the Atlis system is 1600 volts. So that, if you try to go from, say, 400 to 1600 volts, that doesn't necessarily translate very well, right? So part of the advantage of the battery technology that we're developing and being able to, say, pump energy into that very quickly means we can actually take that pack and we can cut it down to 800 volts and we can cut it down to 400 volts dynamically. So when you plug it in, it'll make that change. We can balance the different packs and systems that are inside there very, very quickly. Now, to answer your point directly as to how long it takes, it really depends on what size that system is. So simple math, 250 kilowatt hour battery pack, 50 kilowatt hours, or 50 kilowatt system, right? Let's say it's 5 hours. Okay? Somebody else have a question?
Have you had any kind of contingency plan in an emergency situation? Take, for instance, an example, like I'm back in the woods with my truck and I'm hunting and my buddy gets hurt and my battery's out of juice. Is there any kind of like quick charge package that keeps you down and out, or in that situation, are you thought that far ahead? Or?
So yeah, we've definitely thought that far ahead, and we have a number of people that are interested in whether it's like mobile battery systems or something like that. Generators and things like that, they can work, but not really. It's much more akin to, say, you know, if you're out that far, we definitely recommend don't going so far that you maybe do run out of juice. But if that happens, it would be similar to a situation where you run out of gas. We need somebody, or you need some kind of backup, right, to be able to plug that in and charge it. There will be a capacity, a certain amount of capacity left right at the end of it. That would allow you to essentially drive a certain distance, right, on E. So you can potentially get to a location, right, where you can get help. But that's one of those situations where we can't necessarily predict everything. Yes, ma'am? Is it done?
It's done.
Did anybody time it?
No.
Oh!
We believe it.
You believe me? What's the other one say? I can't even see it. It's not even close?
How do you feel?
21 minutes.
32%.
32%? Okay.
21 minutes.
Who said 21 minutes?
The battery guy.
The battery guy, yeah. Eric's been here. Give you a little story about Eric. Eric, how long have you been here? A week? On his very first day, he didn't expect this, but Eric started work at what, 8:30 in the morning, 8:30 in the morning. He didn't go home till 2:30 that morning, the next morning. So that is the kind of dedicated and fantastic team I have. I do want to give a shout out to them. They're all standing back there, and they're all sitting right behind you. guys and gals for the last 2.5, 3 weeks have worked tirelessly from 6 a.m., 8 a.m. till 2 a.m., 3 a.m. trying to get some of this stuff ready for today. There's a few more things that we did want to show. Unfortunately, those didn't get done, but it's been a fantastic team to work with for the past couple of years. They've done some really amazing things for us. Now, in terms of some of the battery technology and I keep turning the screen off, and where we go from there, one of the challenges that everybody has, and I think I talked about this before, is everyone focuses on chemistry and what you can do with that. Now, chemistry does matter, right? There are different, say, cell types. There are energy cells, power cells, right? There are cells that can do very high cycle rates, like lithium titanate cells can do large power outputs, but they can also do large charge inputs and very high cycle rates, right? But their energy density is roughly a tenth, right, of say what Tesla has in their vehicle. When you look at chemistry and you look at what you can do, when we talk about things like power cells, those are cells that can discharge a lot of energy and they have a very specific chemistry associated with that. Now, what we've actually done is done some things from a, say, cell construction standpoint and chemistry selection standpoint, as well as thermal management standpoint. I talked a little bit about that today. That allows us to actually charge these cells, one, very quickly, but two, work on solving some of those other challenges that are associated with it, right? So when you charge a cell quickly, you get things like lithium plating that occurs, right? Now, and you get dendrite growth with that. Now, there are certain things you can do to minimize the amount of lithium plating that actually occurs in that. One is you try to make it even, because it will happen, so try to make it even all the way across that SEI level, okay? When we do that and we start to actually discharge that cell, we actually start to pull some of that away and we actually break it back down, okay? So we eliminate or reduce the possibility of dendrite growth. Now, you will never, ever, at least until somebody actually solves that problem, eliminate dendrites. Those are things that grow continuously with every cell that's out there. So our focus is on really developing a technology solution that allows us to do this at least 2,000 times, right? So today, your typical lithium-ion battery that you actually build, let's say it cycles 500 times, right? And then it typically drops to 80% capacity. That's a problem, right? That means over the course of that period of time, let's say you charge it once per year, that's 50 times or 52 times a year, you can almost get 10 years of life out of it. In particular, for the work truck market, our focus is on doing this with a cell that can do it 2,000 times, because our typical work truck customer charges once a day to once every 2 days, right? They put a lot of miles on the vehicle. If you're towing and hauling, those become much more prevalent. You don't want a battery pack system that fails, right, within the first couple of years. You want something that's going to last the life of the vehicle. And with a subscription-based ownership model, our focus is really based on building a set of technology that will last for that period of that subscription, and then we go out and kind of replace it from there, okay? From a battery technology perspective, one of the ways we do that is chemistry selection, but really the important things that we're doing is actually in that mechanical construction. It's that brand new cell. I don't have one with me today, but just to put it in a rough perspective as to how big it is, it's roughly about 2.5 inches wide by about I'll say it's 70 millimeters wide by 10 millimeters thick by about 50 millimeters tall, okay? It's this little tiny cell. That cell that I showed on the picture, it looks big obviously when it's up there, but it's actually very, very small. We put several thousand of those in the vehicle, but one of the things we do from a pack construction standpoint is we pack those in very, very tightly, right? The cells are not only designed as a battery cell, they're being designed as a mechanical structure or support component. It actually adds rigidity to the pack and the system without doing things like adding thermoset adhesives to it, right? We really want to get to the circular economy approach. So we're taking the concept of actually developing from a mechanical perspective cell technology that allows us to build structure in the vehicle without adding adhesives that can't be recycled, right? Without adding things that have to be scraped off. That also lends to the advantage that when we do that, we can then, if there's a bad cell in that system, we can remove it, replace it, and keep things going, provided that that cell is a good match for the rest of them that are inside that system. On top of that, from a construction standpoint, at the very beginning of the slide, you saw that picture where you see a bunch of cells and you see a big copper plate on top. By sandwiching these cells together and using a copper plate on top of that and welding that together, combine that with PCBA systems or electrical boards that are inside there, instead of running wires everywhere, right? We can actually build a very, very compact, very, very volumetrically efficient pack, right? No more cables running through the pack. No more coolant lines running through the pack, right? By doing that, we can also eliminate or reduce the amount of fluid that we're using to cool the system. I did mention earlier that the system is submersively cooled. We do that for a couple of different reasons. One, we do it so if a cell failure does occur, right, that system or that cell, when it does fail, if it contacts that fluid, it's an inert fluid. It's not like glycol in water, right, where when it contacts liquid, right? That fluid will actually rust inside there, right, if that little vent pops, and we can actually diffuse that situation before it turns into, say, a thermal runaway condition. On top of that, has anybody ever seen one of those kind of YouTube video commercials where you take this ball, right, and you throw it into a fire, and it goes poof, right, and it puts it out? So we're looking at implementing some of that technology or similar technology into the packs. And that's really, it's like I showed in the picture there, it's leveraging technology that's used to keep your beer cold, right, and employing that or implementing that into a vehicle application. Now the challenge with that, of course, is space constraints. So that's why we're trying to focus on sucking all the air out, right, or in our case, all the fluid out of the system as much as we possibly can. Now one of the biggest things that we could potentially do over the next couple of years is take the cell technology and combine it with solid state technology and other new chemistry solutions that are coming out. Our technology and some of the proprietary aspects of that make it such that as new solutions come, they all face the same challenges, right? There is no silver bullet. People claim it, but in reality, there is no silver bullet to that. So we can actually pull in new chemistry technologies. We can pull in new sort of battery technologies that come about over the next 5 years and directly implement that with the IP that we have today. That gives us defensibility from a long-term perspective. Now the 1.5 megawatt charging station, that is also a long-term play. Any 50 kilowatt, 150 kilowatt, 250 kilowatt, 350 kilowatt system that you're deploying today, it'll be obsolete in the next few years, probably within the next 12 to 24 months. Because as battery technology continues to advance and the need for higher powered charging systems becomes available, all of that investment that we're deploying today, even though it works with existing vehicles, right, it'll be incapable of supplying enough power for the next generation of vehicles. And we know they're coming. We're not the only player. I think somebody asked about, what about everybody else out there that's developing technology and solutions that can deliver this experience? We're not the only player out there that's doing that. We recognize that. But let's build an ecosystem. Let's build a solution, right, that's long-term focused, not necessarily short-term focused, right? The CCS solutions and Tesla's solutions, those are fantastic. That kickstarted the industry, right? Give Tesla a pat on the back for what they've done. They are leaps ahead of everybody else. But it's time for us to actually step up and take a leap ahead of them and start looking where we can go. What's it going to look like in the next 10 years? Now, the reason why we're focused on work, of course, is because consumer transportation is changing. We don't actually know what it's going to look like, right? Maybe we all have self-driving cars and we don't own them, right? We just book it through an app. I personally love to drive. I don't think that's going to change. But the one thing that is everlasting, the one thing that is forever, it has been forever, right, for the last 100+ years, is work. It will always exist. It may change form factors, right? It may change function, but the reality is work is something that is dynamic. Work is something that's sometimes unpredictable. And it's something that is very unique. I showed that picture up there of a truck with a toolbox bed essentially on the back, right? That means that that particular customer, that particular use case, they have something that is very specific to what they're doing. The next individual will have something else that's very specific. And they may have to work in environments and conditions where an autonomous vehicle can't necessarily just simply navigate through that construction site, right? Or if you're like me, you use your vehicle in unconventional ways to get something done. it becomes important. It's a tool. We want to deliver that vehicle and that experience that, yes, it does have autonomous capabilities, but it is a tool. So we're focused on the simple things. Let's build battery technology that works really well. Let's build a vehicle that drives and tows, right, and does so safely. Then let's add all the cool stuff on top of that from there.
Just curious, with the nickel pickup truck that I just heard about, have you ever considered range extending?
With hydrogen?
Do you feel the need for that at all? Or?
I don't. And here's why. I'm not a big fan of hydrogen. I wrote a nice FAQ on that for the site, but in terms of hydrogen, I think it's trying to chase after a short-term fix for something there's billions of dollars being put into the long-term fix. Hydrogen right now is expensive, right? The real benefits that everyone claims today is really range, right, and fill times. You can solve that, one of those two or both of those two with battery technology. It becomes an obsolete problem. Energy distribution from an electricity standpoint is widespread, right? It's pretty much everywhere. There's massive investments in infrastructure to be able to support that. Whereas hydrogen it's kind of like even charging technology in terms of stations, it's $1 trillion problem, right? Let's find ways to make it a $500 billion problem. If we can do that, right, we can really move things forward. The second reason I'm not a big fan of hydrogen, and I say this a lot, water is the one resource that is important to all life on Earth. I know we have big oceans, and I know we can desalinize water and things like that and convert that to hydrogen. We don't yet know the long-term effects environmentally from doing that. And there are certain regions of the world where it's not necessarily readily accessible, right? There's a city in South Africa that I think a couple of years ago ran out of water, a major metropolitan city. When you look at that, right, and even here in the Southwest, right, in terms of water usage and things like that, it's a big challenge to solve, and you can pipe it, you can haul it, but we already have the electrical infrastructure in place. Let's just solve that problem. Let's move forward from there. Now, in terms of range, start with a vehicle that is competitive with what you have today, right? Gas or diesel pickup truck, 32-gallon tank, right? 500 to 550 miles of range. Let's start with that. Let's compete against that. If I were to make a prediction over the next 5 to 10 years, we'll start seeing vehicles that go 1,000 miles with battery technology alone. That will happen. And as that sort of continues to progress, then it makes the other arguments not necessary anymore.
So 500 miles, is that where it starts or is that where it ends?
In terms of
the range of the truck and the battery itself?
Yeah, so that's a really good question. We start at 300 miles for the base model vehicle, and we go to 500. Anything less than 300, why build it? Right, 240, 250 miles, yeah, it's a 50-mile difference, but why do that, particularly for a work truck? It doesn't seem like a necessary thing to do, even if you're trying to drive costs down. I say, let's give an experience that's competitive with what you get today and say the lowest end, right, or a comparable vehicle, like a half-ton gas V8 vehicle with a standard tank in it. Let's try to get somewhere around 300 miles of range and towing capacity from that. And let's work our butts off to get costs where it needs to be so the end customer can afford that vehicle.
Are you developing electric motor technology as well in addition to complement battery?
Yes, we are. We are developing for high level. It's an axial flux motor technology that incorporates a line start function to it as well. Because we're building that pickup truck, right? We're looking for that super high torque right at the beginning, right, and ultra efficiency as we're traveling down the highway. The reason why we chose axial flux versus a radial flux motor that everybody else chose is because of the packaging that we get with it and the torque density that we get with it. Now, there's another company, linear lattice brakes. It's got some very interesting technology that's out there. We're definitely looking at that and what the possibilities are there. But right now we have our own proprietary axial flux motor that we're developing in-house. Yeah.
You talked about the service requirements that you believe to be, what's going to be expected for the vehicle, what you believe the future is. Of course, everything you've got today is likely going to have issues, whether it be something that fails, breaks, you name it. But the second aspect of everything we've got going on here is a service requirement that I'm out on the job site, an engine fails, you name it, mobile service technicians. What do you believe to be the direction that's all headed with?
I'll address it in a couple of stages, right? Every piece of the vehicle should be able to be fixed on the side of the road. Things are going to break. I think we all try to design something that doesn't break, but you can't predict every use case. I come from a law enforcement technology background where I built technology for law enforcement. And we could spend all day in a lab building something, and we think we're really smart when we drop it from 10 feet up and it hits concrete, and I give it to a cop, and he breaks it in the first 5 minutes, right? So design for serviceability and start from an architecture standpoint and then start from a design standpoint and make sure that that is taken into account from day one. Now, when I say that the vehicle is serviced on the side of the road, what that means is our aim is to build modular systems that you can basically unplug and plug another one in and keep going, because downtime really matters, right? If your vehicle is used for your livelihood, one of the most important things is that you're not stuck on the side of the road for 4 or 5 hours, right, at a time, or maybe a day or 2 days time. So being able to have a vehicle that, depending on the industry, you can service yourself, right? That's a big topic in the agriculture industry today, right? With tractors, is the idea that they want to be able to service those themselves to keep those things on the road. So let's build that into the model, right? Let's build that into the business plan and be able to keep that going. But in terms of remote serviceability and things like that, yeah, if you break down on the side of the road, on the side of the highway or something like that, our ultimate goal is that someone can come out, replace that component, and get you on the road within an hour or two, depending on where you're at.
Have you entertained that thought, though, for like the current industry? You have mechanics and shops that are strategically placed where you're driving past and you pull into a mechanic shop of sorts, or you have your dealerships of sorts. Is that changing the industry and seeing with the typical what we're used to, or is this changing the directions and it's a wide open field?
I think my personal opinion is that dealerships won't last in their current form factor. In terms of maintenance locations and things like that, there are some things in the vehicle. Actually, the only thing you really can't fix on the side of the road will be the battery pack itself. Right? It weighs 4,000 pounds roughly, right? The highest rate. It's not something you're going to lower and sort of repair yourself. But in terms of where I see the industry going, it depends on what particular one we're looking at. I'm going to focus on work and not necessarily shared mobility in urban environments where you have fleets of vehicles that go back to a location to be repaired. Where I see the work environment and where that's going, I see that as more remote maintenance facilities. And those that are maybe operating shops today, I believe there'll be a transition where they start kind of transitioning into, okay, this person's on the side of the road, they're 10 miles away, right? We go out, replace that component, and start sort of running from that particular perspective. For everything that can be fixed right away, that's the most important thing, right? If somebody's, maybe they do have a commuter vehicle, right, and they park their vehicle at work, it'd be fantastic if somebody came out, kind of like your windshield, right? Fixed it while I'm at work, and then I get back in at the end of the day, and I drive home, and everything's hunky-dory.
Mark, do you plan to build your own batteries and motor?
Yes, we do plan to get into battery cell manufacturing. From a long-term strategy perspective, that's the best long-term strategy that we foresee going forward. I think if you want to own the cost, you want to own your destiny, you have to own battery cell production. That is currently in the plan. Whether we work with a partner to develop that and set that up, that's in discussion today with certain potential players. But ultimately, we want to own that technology and then, of course, pull in as much as we can from outside. We really want to be an ecosystem solution provider. We don't just want to be a vehicle. We want to be the company that kind of brings that holistic environment to you and gives you that seamless experience. So similar to Tesla and how they do it from a consumer side, yes, we'll offer that to consumers. But again, of course, our primary focus is on work customers, fleet owners, and things like that. This is the concept of the charging, the 1.5 megawatt charging panel that we have. If you look on the front here, there's actually a negative terminal here, positive in the center. Fluid will actually flow up. It flows through the back or the outside here, comes back down through the center, and then all the way back down. cable. And that's how we do that. This, dissimilar to CCS that has, 6 extra plugs and connectors on it for all the communication stuff. From a charging perspective, we are doing wireless communication between the vehicle and the charging station. We are not doing communication over the power lines. One of the reasons for that is because we are pumping a lot of power through that. We want that to be seamless. We don't want any errors or anything there. In terms of logic and control from a safety standpoint, both systems control that, right? So if there's a problem on the vehicle side or it detects a problem in between, the vehicle kills power. If there's a problem on the charging side or it detects something in between, the charging station kills power. By going wireless, we can actually do a number of other things too. We can do authentication between the two systems before we actually start charging. And we can integrate things like pay using cash. So plug that into a cloud service, right? Go into, say, a gas station or a stop like that, right? You have to pay the attendant cash to actually start charging that vehicle. We can actually activate that charging station through a cloud service within that facility or that organization, which is very important for places like California that are mandating.
Is there a consideration for photovoltaic?
What's that?
Was there consideration for photovoltaic either in the charging, the distributed charging stations or on the truck itself?
On the truck itself, there's not enough surface area to really get a ton of power. You can probably run some fans, maybe some of the cooling systems and stuff like that. If you're out there remotely, you might get a little bit of charge over, say, a week period of time. In terms of deploying the charging stations, absolutely. I think in the picture there, it shows conceptually, right, some stuff sitting above it. The problem with that is how much energy you can actually get from it. Now, deploying, say, solar generation on site or something like that, that's definitely an ultimate goal, right? We want to get to that sort of renewable approach. We want to get to that circular economy where everything that we do sort of, comes all the way back around. So conceptually, it is there. Are we going to develop solar technology? I don't think that's a good, sound business strategy today. I think it makes sense to partner with those that are and deploy that appropriately. Sure.
How does the example work?
Okay.
I put my back one trailer like this, and I've got a 500-mile range truck. What's that going to drop? What are we looking at?
How much does it weigh?
24,000.
24,000 pounds. I'm going to do quick math in my head, and I might actually be wrong. Your range may drop to about 200 miles of range in that particular vehicle.
So with that, I know like on my truck, I can put a 50-gallon fuel tank in the back of my truck, so now I can get 400 miles.
Extended range, right?
That
in terms of doing an extended fuel tank or something like that, that's definitely something that we're talking about. The challenge with doing something like that is added weight. But like I said, we're trying to reduce some of that weight, right? And there's definitely technology coming that will get us to that point. And I do think in 5 to 10 years, we'll start seeing vehicles that already start at 1,000 miles of range. So it's a long-term, short-term play, and we have to decide whether or not it makes the right decision to do that right away, or maybe wait a few years until we can swap a battery pack out, right, and load one that can go 1,000 miles.
So on the battery pack that you're talking about possibly putting on site for quick charge, is that something that you're looking at doing at home, where you could quick charge from your home and have it as like a backup power for your home?
It could be done if you had a battery supply or something like that to charge for 15 minutes at home. I'm not sure if there's a lot of use cases for that. It really depends on the particular customer. We do see fleet organizations that are very interested in that. Maybe you're running a last mile delivery company, you're contracting with Amazon to do that, or what have you, where maybe they're making multiple runs per day and they're hauling a lot of product back and forth. I know I get Amazon packages at 11:30 at night from the same guy that delivered it at 8 o'clock in the morning. So when you look at those particular scenarios, there's use cases where downtime matters, right? They get more money, more throughput, right? It's super important, and they may decide to install something on site. Costs and things like that, we don't have numbers of that yet.
Do you know what the cost of comparably to a tank of gas for a recharge of if you want to zero, you want to charge your battery all the way up to full charge versus a tank of gas and diesel? Is it comparable, or is it maybe a lot less?
Yeah, so the last time I looked at this, let's say it takes $100 to fill my tank in my diesel truck out there. It costs about $22 to $25 to put that much energy back into your vehicle. It really depends on how big that vehicle is and what the current prices of either gas or electricity are in terms of the comparison. But it will definitely be, at least in terms of today's pricing, it's significantly less.
Let's say you've got several of these in your fleet and you need to send out multiple crews to a single site. Is there going to be a method to link them together to gain efficiencies while they drive to that site?
You're talking about, I know the term you're talking about, and it escapes my head, but essentially, yeah, you want to chain those vehicles together as they're driving on site.
Right.
I think that's absolutely a possibility. As we look to the future, there's 25 different companies developing that very specific use case and application. So the answer would be yes. We're also looking at how we best integrate, say, cloud services and ownership into those vehicles. So if you have, let's say you have 10 trucks and 20 guys, right, or gals. And each one of those vehicles, when they get in, they move the seat to a certain location, right? They do some of those things similar to today, like you get in a Model 3, right? The seat adjusts to your particular scenario. We want to transfer that across vehicles, right? So if somebody gets in, they swipe their card, they use their phone, right, and adjust that vehicle to that particular user. Now imagine going even further than that. Imagine if you have vocational vehicles, right? Or you have heavier duty vehicles. Maybe the seat orientation and the steering orientation is slightly different. We can, through a little geometry and some configuration, we can basically, if you set your seating and driving configuration in one vehicle, when you get into that next vehicle, you may never have set that up, but we can actually come in and position you within that vehicle in what we believe is comfortable based on your last vehicle configuration. We are also looking at tying in things like how you drive, right? How you like your vehicle set up. Maybe you like it to, maybe you like, super high regen, or you like a stiff steering configuration, or maybe you like it a little bit looser. Let's transfer that across to those different vehicles. As the payloads and weight go up, right? Let's deliver a consistent experience regardless of the vehicle that you drive. And that's something that ultimately could even go beyond vehicles that you own yourself. What if you, perhaps your friend has a truck, right? You hop in that thing, swipe your card, we go up to cloud services, we pull your settings down, load that into that vehicle if they have an Atlis truck. Yes, sorry, I'll get back to you, I'm sorry.
As you start growing, what you see your ratio of software to finance?
I think, Michael, we're at, I don't know where Michael is, but what are we at, like 85% engineering and technical currently with the plan?
The plan for this year is 88% engineering and 12% GMA.
Yeah.
And how about software, the electrical division?
As we continue to grow, we become more software heavy. When I start talking about things like cloud services and some of those software applications, it makes more sense to grow that side of the business and become more software heavy. Oh, sorry, you.
About the XP platform. Forgive me if I missed the price point on that. That's one question. And then I think you said it was going to be ready to pre-order by the end of this year, or what's your thoughts on when it could actually be ordered?
So the ultimate goal by the end of this year is to have a production-ready XP platform to a point where we can actually start building these things in a onesie, twosie, and then sort of scaling from there. You can get online and just at least reserve one and get your place in line. But in terms of taking pre-orders and things like that, we'd be looking at it by the end of this year. That's the current goal, funding dependent and growth dependent.
So your reservation is truly in order of when people put those reservations. Because the last thing you go on is those costing money.
Correct.
So everybody in the world probably reserve them. But without money associated with that.
So to answer the kind of two questions that are there, why don't we take deposits today? We don't take deposits today until we actually have physical vehicles on the road, right, that are out there for sale. That, from an ethics standpoint, makes the most sense. There have been a number of companies that kind of took deposits and used that to develop the company and the product, and then they go bankrupt. One, that's borderline, if not illegal, to do that. We're trying to avoid that situation. Two, we want to be the company that everybody trusts. And until we're at that point where we have things sort of out there and driving on the road, we've shied away from taking deposits. Now, in terms of order, when it comes to that point, yes, we have an entire reservation list, but if someone who's maybe, let's say someone is first on the list and they don't follow through with doing a deposit, right, and going from there, the next person in line is going to bump right up.
Do you have an idea? I'm sorry. Do you have an idea how many people are on that reservation list?
Where's Annie?
It's about 20,000 people.
And what was the price point on that?
Oh, $27,000 to start. Now there's different configurations and things like that for that.
So you have two spots on your truck?
Yes.
You have CCS and your proprietary.
Yep, proprietary plug goes on the side because people pull in and park plugging charge stations, especially for a pickup truck that tows, that doesn't necessarily make sense. Drive-through configuration, so it'll actually sit just in front of the driver's side door. But we did put a CCS system on the front. What's that?
CCS with faster?
Yep, 2.0. That's correct. So that's going on the front of the truck, so we can integrate with other charging infrastructure that's out there today, as well as provide the onboard charging if you want to plug it in at home with a J1772. Sorry, you
Are you guys using like any blockchain technology for applications?
Not currently, no.
So what are your plans for a build kit for the XP? Do you need brakes, steering, belts?
Yeah, so the plans for the XP platform is actually that if you were to order that, you would actually get the steering system, the center console, and the dash as along with that XP platform. You would, of course, have to build that integration into whatever vehicle you're plugging it into. We do have a number of customers that are very, very interested in that to retrofit their fleets of, say, 300,000 vehicles that they currently have today. In that particular scenario, the business strategy is to partner with someone or set up a location to help facilitate that at the fastest rate possible.
Is there going to be able to buy stock in this?
We've done 2 crowdfunding rounds so far. We're working, I guess, on a potential A+ offering here in the next couple of months, but we'll keep everyone apprised as that kind of move forward.
You said they start at 27. Where do they end?
That depends on what you're building and how big of a battery pack you want.
If you wanted the 500-mile one.
I don't want to don't hold me to this number, but think somewhere in the 50K range. So off the top of my head.
If you, let's say you're out in the middle of nowhere, you run out of juice, or you're using too many tools plugged in the vehicle, something like that, is there a way to pull an emergency charge from someone else who has a similar vehicle?
Yeah, in fact, your Atlis truck could technically charge your Leaf in a couple of hours. So, yeah, absolutely.
So the question I have, the price point that you're talking about, are we talking about like a skateboard here? Are we talking about a complete truck?
So the starting price for a complete truck, 300-mile range, 4-door, 4-wheel drive vehicle is expected to be $45,000. That's a line we drew in the sand. That's a price we will hit. That we have to remain at kind of competitive in that particular space. As the vehicle sort of moves up in capacity, right, and capability, then of course the prices associated with the additional things that are put in there. In our particular case, in the way we're architecting the vehicle, most of that cost is generally just in the battery pack and the technology that's going in there, right? If you want to tow 35,000 pounds, the motor's, gearbox, everything will take that, suspension will take that, right? But you just have to upgrade the battery technology to be able to do that and do that at distance.
One last one. Manufacturing jobs. Where are you going to do all that?
So, right here is where we're growing currently, but the plan is to actually do a large majority of that right here in Arizona, mostly because I'm biased. We're probably, I think, we're looking at somewhere around 1,200 to 2,000 jobs over the next 3 to 4 years in terms of what we're actually going to bring to the state here. There are some other concepts for like micro factories and things like that that we're looking at. The ultimate goal would be you order a pickup truck and you get it in 2 days. I'd love to be able to facilitate that, but there's some challenges around that have to be solved. That's part of the modular architecture and our approach to that as well. We do, yes. We have, in particular for the battery technology, we actually have one pending patent with a large number of claims associated with that. Patent attorney down here, actually East Mesa, that we work with on some of that stuff, and then provisionals on some of the other technology and things like that we're developing.
After we purchase this truck and we find down the road that we need more towing capacity, can we add battery to it at that point?
I don't have an answer for
Trade
you.
it in again?
Yeah, I don't have an answer for you on that particular one yet. That's something that a lot of people have asked for that, and we'd have to definitely like dig into that and understand the application. There's challenges around that, right? In terms of how we do that, how we, like if you're a subscription owner, that's different versus if it's a direct purchase.
So your first truck will be what, half ton, 3/4 ton, 1 ton?
The aim would be a 3/4 ton truck to start, which could scale down to a half ton, and then shortly after we aim for that 1 ton.
The first one out will be 3/4.
What's that?
The first one out will be 3/4.
Yep, to aim for that particular use case, and then to go to a half ton is just a smaller battery pack. Yes, sir.
Does the capacity increase when you move to a full ton?
I'm sorry.
Does the battery capacity increase as you move to a full ton?
Yes. Yes. Someone else has their hand raised over here? Yes, sir.
So regarding the software, are you planning to push updates that vehicle as they come through, or everyone they have to change to whatever it may be, or similar to kind of what Tesla's doing now? And the second part is the data that you're collecting of the trucks. Do you see that as a revenue source for, in the spirit of traffic, not going to sell you your data?
Answer your second question first. Do we see data that we collect from users as a revenue source? I think that comes into a ethics decision there. My gut says no, right? I don't want to do that. Now, what we do with that data, in particular, in relation to your first question, is imagine driving a vehicle similar to Tesla, where things like towing capability, traction control, how it tows that trailer, right? We start with 35,000 pounds that meets compliance today. In 2 years' time, all of a sudden your vehicle tows that 35,000 pounds maybe a little bit easier, a little bit better, right? Maybe it performs better on the road. Collecting that data and being able to continuously update that logic is very important. I think that's a great value proposition, especially for those that, whether you purchase the vehicle directly or you do a subscription model, right, you're looking for something that continuously improves over time. There are some things with machine learning and stuff like that that we will get into, right, in terms of implementation of everything from traction control to something else. Every user is different. In terms of the XP platform, a fantastic model would be you put that under like a C10 truck, or you put it under a box truck, or you put it under something else. When you do that, that vehicle then downloads that particular configuration and information so it knows how to behave in that particular scenario. So you take a drive module and you swap it from, say, a pickup truck to a box truck, or a medium duty, like Class 5 truck or Class 6 truck. As you do that, the master controller in there will basically come up, grab that information, pull it down, configure that drive system to perform for that particular vehicle application. I'll go with you first, and then you know, move across.
With cloud access like that, is there possibilities of hacking?
There's always a possibility of hacking, and you have to do the best that you can, right, to make sure you have the appropriate security implementation in place to prevent that. But it will always be a possibility. All we can do is continuously work to make sure it's the most secure connection possible.
So would there be possibilities of shutting the access to the cloud off in the truck?
I wouldn't comment on any of that. I would say that we will implement certain security precautions to do the best we can to prevent that.
So let's say I have a charger in my house. How much power is that going to take in my house? What's that going to like?
It really depends on where you're at, right? Here in Arizona, right, you're charging during non-peak times. It's going to be a little less expensive than during peak times. If you have a 200, let's say it's, I'm going to use an easy number for math reasons. You have 250 kilowatt hour pack, right? You have a 10 cent per kilowatt hour charge, right? You're talking about $25 cost to charge the vehicle full.
Even cheaper when you do super option,
right? 7 sets of controls.
Yeah. So I picked 10 because that was easy math. 250.
You talked about the availability to swap in based upon your different models for battery packs. Are you guys writing your own software for that?
Yes.
And you talked about patents. Do you guys have patents for that as well?
We have. I can't comment on the number related to that, but to answer your first question, yes. We started using off-the-shelf solutions similar to what we kind of displayed here for implementation of basic features. But as we look to the future, we have to own that sort of BMS technology that's out there and some of the software that's written. Off-the-shelf solutions today don't meet the requirement for something like fast charging. There's a number of things that we do there with regards to how we manage power in that cell or that pack and those sets of cells that allows us to do this that BMS systems can't do today.
And then kind of a follow-up as well. Have you guys looked into, you could take that into different industries such as racing and stuff like that, just be able to go and download, okay, I want to do this for my truck, I want to go dirt racing this week, and then I want to go take some
I think we have a number of guys that want to do like the Baja, races and stuff like that. That'd be awesome. I think Derek will probably build his own version of it. He'll probably actually take an XP platform and throw it into UTV as well. But those are definitely things that excite us and we find interesting. The most important thing we can do today, though, is remain focused on what we're trying to deliver right away, and then we do all the fun stuff after that.
I have two questions. First is in relation to a warranty. What can I expect as a warranty if I'm purchasing a vehicle outright? My second question is in relation to wireless charging. Are you guys doing anything to align yourselves with companies that are working on wireless charging technology?
So in regards to the first question, we have some kind of requirements that we've set in terms of warranty for the vehicle, things like 10-year warranty for certain components. Sorry, just something fell over there. So 10-year warranties or the expectation of 500,000 miles to 1 million miles for something like the battery pack, the drive systems, and things like that. Specific structure around that, details are not written yet, of course, and those will come out as we kind of transition from there. If you're a subscription vehicle owner or you buy a vehicle and pay for what we would call a continuation subscription or maintenance subscription, then obviously things like everything is basically covered in that. That would be your insurance, right? That would be your payment. That would be maintenance of the vehicle and things like that. With caveats that if you drive it like people drive a rental car, right, then it's probably not going to work out. But that's typically how some of those things are structured, and more details will come as we get closer to that.
What's the expected depth of water this vehicle should be able to cross?
1 meter.
1 meter. Yeah. And also, second question: if you are real hard on your trucks and they just get banged up real quick, but obviously there'd be nothing wrong with the battery pack or anything like that, can you purchase a new upper body section to mount onto your lower frame?
Yeah. So I think. The best reference is the Tesla demo, right, when they took the sledgehammer and hit the side of the truck and they're like, yeah, it doesn't dent, but we all know that like everybody takes a backhoe and a forklift to the back of the truck. There's not much that'll really survive that. Something's going to get dented and broken. So making it as easy as possible, right, to replace components and things like that. As we look to the life of things like the subscription model, I talk about circular economy and where we see that going. So the concept or the idea behind that is that we take a new truck, right, that has components and things like that. If you're under a subscription model, if things break, we pull from, say, a parts bin of maybe other vehicles that are kind of broken down into different components. We come in and replace those as we sort of cycle that through. That vehicle then goes from one owner to the next owner to the next owner and to the next owner and through. In each one of those transitions, there's always the possibility that the XP platform is rock solid and the vehicle body is destroyed to some point. The ultimate goal is to be as simple as we're taking 6 bolts off and a number of electrical connections, lift that off, put another one back on, plug in the electrical connections, put the 6 bolts back in, and away you go. That is the ultimate goal.
The subscription service be available for the platform as well, or just the truck?
That's a really good question. That's something that we're definitely contemplating because as we look to markets where they would maybe take the XP platform and integrate it into something like an RV. Those are kind of some discussions that we're having today. being able to offer that subscription model for that drive system, the charging network, right? Some of the maintenance applications maybe beyond what the coach builder actually puts in there. Those are definitely some things that we are kind of having internal and external discussions on. The ultimate goal for Atlis Motor Vehicles is not just to be an OEM, right? We don't just want to be a vehicle manufacturer. We want to be an ecosystem company. We want to provide you with the sort of holistic solution of your entire ownership experience across the different vehicles that you do own. I love RVs, right? If I was in Michigan, I would say I love boats, but you know, out here in the desert, right, we love RVs. It would be fantastic if each one of the vehicles that I own, from the car, well, we won't build cars, but the trucks to the RV and everything else, when I get in it, right, it knows that it's me. It's already configured to drive the way I want it to drive, right? It already works with all of those cloud services and systems and things like that. And if a maintenance problem does come up, then there's only one location I go to, right? I call up Atlis, and whether it's a contract technician that comes out or it's an Atlis employee that comes out, they all repair and fix that vehicle. That is the vision. That's what I want. That's, I think, what a lot of people want. They want that assurance. They want one place to go, right? They want the best possible experience.
Your drive-by-wire system, is that include brake-by-wire?
Yes. Yeah. The coolest thing that's possible with a brake-by-wire system is imagine what you could do from just a traction management standpoint, right? Or moving that from vehicle to vehicle or different types, and continuously improving that over time. Glenn. Oh. Okay. Do you have a question, sir?
Yes. I think it's time to kind of wrap everything up, and everybody can ask questions individually and interact with everybody. So maybe one or two last questions. But yeah.
So I guess I would have a question for the audience here. You know, the battery technology and things like that. Obviously, we're doing some very unique things there. We're doing some things that are different. We can't necessarily share things like deep technology and stuff like that. Unfortunately, that's a little too proprietary. But are there any very specific questions about that maybe I could try to answer that you're curious about? Or what were your impressions of kind of today?
What are your goals on the cobalt and rare earth elements?
Cobalt-free would be fantastic. Rare earth elements are always a fantastic thing to try and walk away from. In terms of our approach to that, it really depends on what we can do today versus what we can do tomorrow, and obviously sort of march towards that sustainable solution. Ultimately, we want to get to a point where a vehicle we build today, that technology goes right back into a vehicle that we build in 10 years from now.
Are your motors permanent magnet or induction?
Permanent magnet with a line start component that's induction based.
Is your battery graphene technology?
Graphene technology? I don't want to share necessarily that. Yes, ma'am.
The significance of the tractor trailer is just the stage. Is there significance, or is it just because it was most convenient? I find it really creative.
Yeah, so one, it's convenient, we needed a stage. Two, we're work oriented, right? The platform was actually hauled into this room on this trailer, right? This is what I towed it here with my truck. This is what we use to haul the platform around for all the photo shoots and everything else that we do. This is, you know, a very, very rustic interpretation of, work, right? And what we're about.
You guys have a full prototype built yet? I mean, it's pictures of it all. I don't think you actually have the truck itself.
The truck is
where we can take a look at it.
The truck is not yet completed. Yep. So we're still working on that.
I would chime in that Ross did a really awesome VR experience in one of these conference rooms. If you haven't tried it, it's very cool. And you can see the truck like it's real.
Go ahead, sir.
So it's a pretty big platform, and it would be good to do a car. I thought we were a smaller platform for a sport truck, or we need these size.
So when we talk about like a mid-sized truck or smaller trucks, that's definitely a discussion on the roadmap. So whether or not we go there, right now our primary focus is kind of class 2 and above, and aiming for that particular market. market and owning that space. And then we'll look at how we can scale that back down to something that's a little bit smaller. The problem with the mid-size truck is that it's a little skinnier, a little shorter. Well, maybe not shorter, but it's a little bit skinnier.
My last question, will you be able to raise and lower, maybe not on the first platform, but in the future, the entire vehicle or just the bed section for locking up trailers or ground clearance issues?
So both, actually. So when you park the vehicle, of course, lower to make it closer to the ground. Because we're putting that frunk in there, right, with the fold-down gate up front. Currently, right now, as it's designed, it sits about my waist height, roughly. And then, of course, we can actually lower that down to an even lower scenario for individuals that are like 5 feet tall. They can't necessarily reach all the way back there. But absolutely, it'll raise and lower, and then it will get to a point where if you load the frunk up with 4,000 pounds of weight, right, I don't necessarily recommend that, but you technically could, given the capacity of the suspension. It would adjust for that, both from a spring standpoint and a dampener standpoint. Oh, blue, yeah, sorry, I was going to say blue shirt, but yeah.
So my buddy, he's got a Silverado diesel and he lowered it because he's in a wheelchair so he can get in and out of it. What's the lowest the truck can go? Because it looks pretty high up, you know, when you think of the floor plan being right up there.
Right. So right now it's sitting a little bit high. How low? I can't remember off the top of my head how low we're going. Derek's too tired to answer. So the ultimate goal would be to get it very, very low, but for someone who's using like a wheelchair application, obviously we'd look for a partner, of course, to also help develop systems that allow make it easier for them to get in and out.
Yeah, okay.
Four-wheel steering is still an option? Four-wheel steering is mandatory.
Oh.
Yes. So on there, the rear is fixed, but yeah, four-wheel steering is something that we definitely are very, very interested in implementing. We're also looking at solutions where you can even drive the thing in reverse. So that would be a very cool scenario that I think people would be interested in. Okay, so appreciate it, folks.
Wake up, step into the world outside. The future never looks so bright. Can't you hear it calling us? Let go, leave all of your cares behind. You never know where you might find sunny days are coming up. Dreaming of tomorrow, soaking up this sun.
It is February 21st, 2020, and we are at Atlis in Mesa, Arizona. Get the Atlis team here. Doing big things today. We're about to cut the ribbon. First battery power day. This is very exciting.
All right.
Let's go.
You too. Bye.
Dive into the deep blue sky.
Yes! The cheesier the... You're such a Midwesterner. Anybody have any words? Are you excited? This is a big deal, guys. I know. Okay. Yeah, he's smiling. Yeah. Slow motion. Can you do it over? Yeah. Woohoo! That was so cool to witness in person.